thanks to the SCT for inviting me to give this presentation today. So what we'll try cover is just the various elements of smart home technologies, the moving parts, how it fits into operators' networks and the opportunity that it gives operators. I was handed a title, so unfortunately it's difficult. So basically it's the fragmented smart home. So what we're talking about here is, this is a bit of an eye chart, but it tries to tease out that there's hundreds, if not thousands, of different players in the IoT space today. And it's getting more and more difficult for operators to work in the space because they're now becoming the actual IT department for all of the retail, for all of their subscribers. It's becoming a major problem for them. There's new entrants coming in, the likes of Google and Amazon are coming in, and they're kind of doing this Trojan horse play where they're actually dropping their equipment in, and then suddenly you're losing your customers. They're suddenly taking your customers away from you. In general, there's a lack of cohesion amongst all of these players. Some companies are trying to pull them together. There's some examples like If This Then That as a technology solution where it tries to pull the different ecosystems together. But if you look at the different players, like in the Internet of Things, we have home automation elements. So we have the likes of Nest that you're probably all familiar with, August, Yale, Philips, SmartThings. So these are the base ones for managing people's homes. But then we go on to the more wearable stuff that you still have to interact with in the home. And this is something that people are probably more familiar with rather than the actual Internet of Things. And then we have the platform systems. So you can see here we've got Google, Amazon, they're all playing in this space. The likes of Comcast are quite busy in it. And then Control4, Logitech and others, and HomeKit from Apple are all very well established in the space. Again, some of them are trying to build ecosystems, others are trying to spread out and take on everybody. So at the moment it's quite a disjoint experience for the customers. They go out to a retail shop and they buy all sorts of different equipment. And this is what you end up with in people's homes, quite a mixture of products that don't work with each other. Different software components, different devices, different onboarding experiences. When people pull a tab out of an IoT device, they don't know what to do with it in a lot of cases. And the problem now is it's becoming an OpEx headache for operators. They're having to deal with the customer support calls. How do I fix this button, or how do I get my Amazon Alexa working? Or why can't I stream content around the house anymore? So the challenge here is how do we get the operator to maybe play a bigger part in this and maybe get payment from it. So Arris basically does a survey every couple of years. It's a consumer entertainment index survey. And what it tries to cover is 19 different countries and a sample of 1,000 people in every country. Out of that, it's a mix of 50-50 male-female. And pretty much across all the different age groups, there's maybe about 18% over every 10-year bracket. So this survey was done just to see if subscribers were actually interested in smart home technology. What we see is that a lot of people already have it, a lot of people want to get it, or they'd probably be convinced to buy it. So you can see, across a lot of the European countries, there's a significant number of people very, very interested in taking on this idea. So we now see that there is an interest there. And the next thing is whether they would like somebody to manage this smart home space for them. So one of the key things we found here was that internet service providers and TV service providers were some of the most trusted people to actually manage this IoT smart home service. The total of 47%, which is significant. And obviously the other people are the likes of those home security companies, insurance providers. One of the interesting things here is the utility companies come in 4%. And if you look at Hive is probably, British Gas's Hive is probably one of the most successful IoT launches ever. But still only 4% of the surveyed people were interested in the utility company actually taking on that role. It may be because these guys are already dealing with technology compared to the utility companies. It was one of the reasons that happened. And obviously, there's no point doing this unless you're able to make money out of it. So what we did was we asked the question, how much would they pay, with different brackets across the actual range from nothing to more than $40. And what we could see here was, 36% would pay between $1 and $10, which is a significant amount of money on a monthly basis for operators to add to their base subscription. More interestingly, 35% would actually pay between $10 and $40 for this. But obviously, doing something like this, it has to be a credible solution. It has to be able to take all the pieces in people's homes, put them together in a meaningful way, and take the burden away from the subscriber. So it all just happens in their home. Another point that we spotted in the survey was that 64% would actually like it running on an existing bill. So this kind of goes against the idea of people splitting away from their cable TV service and buying, IP content on an as-need basis. Here they actually wanted to incorporate it into a single bill. So the service providers right now, be it cable or telco or any of the service providers that are out there, they seem to be very well trusted by subscribers. I know sometimes there's a bit of bad press with service providers out there, but in general, the survey indicates they're very well trusted. People are already doing this by themselves, so they're putting a lot of money into it themselves. Some of these IoT systems are very expensive. And the problem is that in some instances they'll buy an ecosystem like an Apple ecosystem and be happy with that, but then if they want anything outside of that, it doesn't work, it doesn't integrate. And they like a single billing approach. So obviously the service providers today make a living out of making these complex solutions appear simple, right? These are some examples like 400 plus channel TV experiences, VOD services. These are very complex back office pieces that rely heavily on cloud services and other back office systems to do that. The recording service in NDVR, that's a hell of a lot of equipment to actually put together to make a service work. So service providers have proven themselves in this space. So obviously this should be easy, given that everything else has been done so far. But what we see is it's not that easy. There's a lot of work involved with putting all of these pieces together. And what we're going to do in this section of the session is just to go over the different IoT elements that make a smart home. All the software components, the hardware components, the cloud pieces, and even some of the more advanced features that people are coming out with now, the smart assistants that involve voice and audio control. So this is just a sample of what you might experience in an IoT environment. On the far right-hand side, you see the smart devices. You can get them in retail, you buy them online. We've done a lot of research ourselves in Arris where we actually buy all of these components and try to stitch them into an existing IoT system. And one of the things we experience is a lot of trouble trying to onboard these devices, deal with the different proprietary systems that they use themselves. But those smart devices are really, that's what is being talked about when people talk about 20 billion devices or 10 billion devices that are going to be deployed. The next piece is the PHY protocol. So this is the communication layer these smart devices require. So we have Wi-Fi, which everybody knows about, Bluetooth LE. But we also have 802.15.4, which is the basis for Zigbee home automation, Thread, 6 low PAN. So these are layers that people have developed over the last couple of years for low-powered wireless personal area networks. So those technologies exist for some time, but now people are starting to see different ways of put software on top of those protocols. So we see in the onboarding protocols section a whole array of different systems that people have started to use. We have the Open Connectivity Forum, which is a consortium of maybe 200 plus CE vendors that have been used that have come together to try and make a standard that everybody could use to simplify the PHY protocol, the smart device, and getting these devices into an IoT hub. Thread is a big Google push. MFI is tied in with HomeKit from Apple. And Bluetooth has been around for quite some time. So in a lot of cases, as I showed in an earlier diagram, we get these little small boxes that need to be plugged in to enable these smart devices work. So that's where our IoT hub happens. So it takes in all of these protocols here, mixes in the onboarding protocols just to provide a single solution which typically connects to the cloud. On the cloud connectivity side, we have proprietary systems. We've open connectivity again, Google Brillo and Apple HomeKit as options for connecting these devices. Today what we see is a lot of these devices, there's very little in the hubs themselves. The intelligence is in the cloud, and the cloud is exposed through the smart device, the mobile phone device. So the experience really is if this link fails, the device is no longer useful, which is a challenge. Particularly if it's the service provider offering the service, it has to be always on. So the question then is there a way that we can take a hub and have it take over the functionality for all of these other devices? So on the right we have new devices like the Amazon Echo, Amazon Dot, SmartThings, Google Home, a few other IoT devices. The example on the right is just a broadband gateway. So what can we do with the gateway to be able to take over controlling these devices? And the idea is that we take an existing broadband gateway. It already has a bunch of features that people are using for these IoT devices, typically the 2.4 or 5 gigahertz Wi-Fi. It's got plenty of RAM, flash, CPU in a lot of cases, where it can actually take on extra functionality. It can take on new software. And another interesting thing is it can actually hook into existing set-top boxes. A lot of set-top boxes nowadays have Bluetooth as their remote control interface. So those Bluetooth devices or receivers in the set-top are actually quite useful. We can pair devices. Any of the devices that you can normally pair to your phone can be paired to a new set-top box today with Bluetooth. And obviously using 5 gigahertz or 2.4, we can connect to an external hub. And the point there is maybe if we need a Zigbee radio or a Bluetooth radio, that exists in there rather than in here. So the idea here is investment protection. How can we use the existing gateway that's already deployed, probably anywhere from $60 to $100 today? How can we exploit that rather than having to replace it wholesale? Now we do have some challenges, all right. I mean, with RAM we're typically okay in a lot of cases, but flash storage is quite a challenge in a lot of boxes. We run very, very low in flash today in most broadband devices, purely because of the cost, right? Service providers spec very low flash requirements, hoping that everything will fit in there. And 10 years later, they're still putting features in, and there's no flash left. So we have a challenge there. Now, as I said, we can connect the gateway to some other devices. So when I mention peripherals, I'm not talking about a USB stick. I'm talking about a separate device that exists in the home. The first thing is the extension device. So maybe somebody has poor Wi-Fi in the home and they need an extra extender somewhere in the rest of the building. So rather than just have it do Wi-Fi, let's put in some extra radios at minimal cost. Alternatively, the set-top box. In some cases, it does have 15.4 radios. It has an XRE, not an XRE, it has a Zigbee profile for remote controls, which is possible to use for other functions. But generally, it does have Bluetooth in there. So having software control between the gateway and the set-top box gives us an option of extending into the IoT space. And the last one is the notion of a smart assistant device. So you've all heard of Google Amazon, or what is it? Amazon Alexa, Siri, and all these other services. They're now coming out in little small boxes that are deployed in people's homes. They're taking on more functions and features in those boxes. So they're actively putting in Bluetooth as an extender, but some of them are putting in 802.15.4 as an actual radio system as well. So they're putting the cost into these to support these IoT applications. Alternatively, if you decide that you can't stick with a single platform, maybe your gateway just has no flash left, the alternative is to look at a new ultra-connected home gateway. So we won't worry about this in this slide, but these new future home gateways are looking at integrating Zigbee, Bluetooth. In some cases, they may integrate LoRa as another radio interface. They'll definitely look at pulling in 802.11ax as the next generation Wi-Fi standard, as well as 60 gigahertz AD. So AD is this notion of wireless HDMI, which you may have heard of, for basically taking content from a set-top straight to a TV without any cables. But we're also looking at wireless, or that 60 gigahertz service as a fast sync option in people's homes. The last thing here then is actually the software, which is probably the key in all of this. I mean, we can add radios very easily, but software is what makes everything work together. So we're looking at putting virtualization to use in the actual CPU devices themselves. So we can take advantage of the extra RAM and flash that's in there and get the CPU to do a bit of work for us and put a lot more software in there. So we can have service providers put software in there, or we can get third parties to drop software in there. If we do the virtualization properly, we can create a sandbox that third parties get to put their software in there. So that may be your favorite IoT vendor that gets their software in there, and they get access to these different radios that are available on the platform in a safe, secure way. The other point about the Ultra Connect Home Gateway is it may actually start to integrate some of these microphone and speaker options as well. Now we get onto the piece about software. So there's a couple of different moving parts. Obviously, we talked about Bluetooth before. Bluetooth is only one kind of layer that people use, but we have to consider Wi-Fi, Thread, ULE, Zigbee, all of these other protocols. So there's software stacks available for all of these things today, but in general they don't work too well together. So the Open Connectivity Forum, which started about 18 months ago, integrated about 200 CE vendors to try and work together to produce a single standard. So you'll have Whirlpool washing machines working with Samsung TVs. That's the whole idea. The specification puts all of this together. They acquired the UPnP Forum assets, which was another big IoT player, and All Scene Alliance was another company that was used. It was tried to be created by, I think it was Qualcomm, to set up an IoT standard that everybody would work with. This group produces this software, so it's an open source framework. It ties together it can tie together all the radios at the bottom and all the components around the text there. And it provides a single way then of allowing devices and applications work together with the IoT layers. So from our own experience within Arris, we've created a lot of different demos and ecosystems using this OCF IoTivity framework and have shown how all of these different standards can work together in that software environment. So we've done it as a proof of concept. A lot of people are looking at doing it as a real product. And then obviously once you have the specifications sorted out, you need to figure out what you're going to do in your virtual or in your standard gateway. We have, on one side there, we have Docker, which is a virtualization platform, it's not Docker, it's Linux containers for virtualizing what's running in your gateway. So if your gateway has say 1 gig of RAM, you can easily split that up to have many, many different small applications run, as long as you have the right framework to actually run that. Some other people are starting to look at using JavaScript. So a lot of people build software targeting a specific piece of hardware. And the problem with that is it's not portable. So if you've got 6 gateways out there, you've got a problem because you have to build it 6 times and test it 6 times. So the idea here is we're looking at Node.js or other JavaScript frameworks where you can drop portable code in that will take advantage of IoTivity frameworks and allow you to have a standard piece of software running inside a box that can be portable to different boxes. And the whole point here is these services like IoTivity give you the standard platform so you can isolate out all these low-level radio details. You don't need to be messing around with Zigbee packets or Bluetooth packets anymore. It's just a frame that comes from a device. You don't care what the file layer is. And obviously, we can do all this stuff in the gateway, but you still have to try and give your user something to hang on to. So the idea here is that we actually consider the TV/set-top as the IoT portal. So it gives people an extra chance to be able to use a screen this size to monitor all of the IoT devices in their home. There's a number of points here just about why we think that's a very good idea. Obviously, service providers right now do a lot of work to try create these set-top box UIs that are captivating and are usable. The other thing is, it's a nice, tidy ecosystem. It's not like software running on many different boxes in your home. It's a single box. It's generally controlled. There hasn't been too many cases of set-top boxes being hacked, unlike a lot of IoT devices. And then obviously the customer familiarity with the set-top box UI is key. Particularly the older aging population, which is classified now as anybody above the age of 55, so probably covers a lot of people. But I guess the challenge here, or not the challenge, but the benefit of the UI is that if you're using your set-top box, you don't need to fumble around for your phone. Pick out your phone, try to figure out which of the 50 different apps are controlling your IoT environment. You have a single UI. We have an example where we tie all of these different pieces together into a UI that we'll show in a second. So what we've tried to do, we've taken the IP set-top, which is Bluetooth embedded in it. We have the Wi-Fi gateway, which is Wi-Fi embedded with it. Voice remote control, which hooks up to the set-top box. And then a separate hub, which gives us the Zigbee control. So this is a legacy gateway, a legacy set-top box, a deployed voice remote control. So this isn't new equipment. The only new thing is really this hub that gives us the Zigbee connection. But we've been able to manage and model all of these different devices into the UI in a very user-friendly way. So this is just an example of the UI that we put up on the screen. So you can imagine in this example we have the main gateway that we showed earlier. We have a couple of extenders it can connect to. The color coding is just more for Wi-Fi devices and trying to show their performance within the home. Green is good, red is bad. But we try to show here the Internet of Things connection. So we just try to use as much screen real estate as we can. So that's obviously a lot better than a small mobile phone device that you're going to have in your hand. And then just to build in the IoT pieces, what we did was we modeled all of the different rooms and then mapped all of the different IoT devices and be able to create a single connecting setup where from a voice remote control you could actually say to the system, turn on the portico camera. So it would take this the camera that's embedded in this room here, turn it on and actually display it on your TV screen. So it really tries to make use of the TV and set-top box experience in a lot better way than a mobile device will give you. Obviously there's challenges here. It's not portable, right? It has to stay in your house, so you still have to have a mobile app. Okay. And we'll just move on to smart assistants. So these are the systems that are coming out thick and fast at the moment. A lot of service providers are looking at them as enablers. They're not saying that they're necessarily competition. So in the case of making a personal assistant, if somebody was to make a device like this, that they would be able to take advantage of Alexa or Cortana or Google Voice or Google Assistant to be able to actually build a big service. And what we've done ourselves is we've created something like this, which comprises of Bluetooth, Zigbee, Wi-Fi, microphone, and speaker, and fully integrated with Amazon Alexa and driven that actual set-top box UI as a demonstration. So I'm not sure. Yeah. Okay. So what we're trying to go through here is basically putting all those pieces together. And what I'm trying to demonstrate is we have third-party hubs. So this is an example of a house. Third-party hubs already there with the IoT devices, and generally what happens is they've got cloud connections. So the software is running here, the hub is just a conduit. We have cable gateways that don't have IoT radios, and cable gateways with IoT radios. So these are likely to be new gateways. But we have to consider the legacy devices that are out there. So how can we control them? So we have thought about the use of an IoT hub to do this extension. In the back office then, so there's a big divide down here. This is in the home and this is the operator back office. So people are already starting to create cloud infrastructure, be it through Amazon or do it by themselves. And they're building these this microservice infrastructure that allows them to put new apps up here into the network that are able to work collaboratively with the gateways. The idea we have here is that we drop in our JavaScript engine. We have, local running services. We have third-party provided services embedded into the JavaScript engine. And this is running locally in the actual home. We have also started to look at how can we download this, because if you're familiar with most gateways, it's a single big image. It's a 50 meg image. You push it down. If you want to make a single comma of a change, you actually have to put a new 50 meg image down there. It's very wasteful. It's time consuming. It causes problems because potentially bugs creep into the actual image itself, causing you to have failures in the field. You want to try avoid that. So what we're looking at is a downloadable JavaScript environment where you can just drop JavaScript in there, run it, replace it if it needs replacing if there's a problem. But it's just a much lighter weight. You can put 200k down instead of 50 meg down, so it's a more manageable solution. The other piece is we're using this virtualization type subsystem where we're able to take all of this downloadable JavaScript and the engine and protect it, or protect the gateway from it. We try to isolate everything away from the working of the gateway so that this is more secure. And if we have a problem, we can just kill this without taking down the cable gateway. So we have a much more secure, manageable platform. The other benefit of having this container approach is that if operators are interested, they can start to deploy other software in here other than IoT. It doesn't have to be all IoT. It can be other pieces of software they want to use. So obviously we've got the framework in here. We can start to pull IoT devices into the hubs or into the radios. Oops. And the idea then is that these now connect to the cloud infrastructure where we have applications running. So we either have are up here. In the event of a network connection, which is nice here, these apps still work. We don't lose the whole home. We just lose a small bit of functionality. And obviously, it's up to the operator then to see, based on various economic reasons, which third party they might want to integrate. But the other benefit of considering the third party approach is maybe they don't want to be selling these hubs all the time. Those hubs cost maybe $30, $40 before you even have an IoT device. So the idea is that we can actually migrate the third-party elements into the cable gateway infrastructure, pretty much get rid of these, and then have a relationship between that third party and the service provider itself. So the nice thing here is we're more than just this dumb pipe that exists today. We actually become part of that whole ecosystem. We try to extract value from it in the service provider space. Right. So, and the other idea here is that once we pull these third-party services into the infrastructure here, not only can we manage these elements, but we can also tie the whole element together. So we're able to, if you, as an example, if you consider this as a third-party light, and this is a light switch, but this whole ecosystem, based in a cloud, would be able to manage this light switch turning on this light, right? So that might not seem very difficult to do, but based on all of the kind of commercial agreements that you have to put in place and all the infrastructure, that's a huge challenge. But that's what service providers are actively looking at today. So just on the basics convergence summary here, there is a potential here to use the broadband gateway to service the home elements. We have the radios, we have the interesting ecosystem. We can put in extra hubs if we have to. It's not just a throwaway gateway that we have there. We can try to exploit it. This is an interesting one here. The cost savings, as I said, the hubs that come with all these IoT systems are about $30 each. So if you're able to break that away from the third-party package, it means they're making more money and potentially you're able to leverage some of their value chain. We're doing this anyway in terms of putting the frameworks into the gateway. And we're mapping the IoT devices using these frameworks so that we're able to isolate the functionality in a single platform and manage it properly, as well as connect it to the cloud with the various connectors we've talked about. I'll just give you an example as well now of somebody who is doing this. So there was mention earlier about Comcast. So Comcast is already pulling together their Xfinity service as part of their whole digital home system. First step during the setup was basically to record the different devices that are in your home using their app. So they just allow a very simple experience of QR coding the actual gateway and then pull in all the different devices in your home as managed devices in the home. They're doing this with this XB6 Wi-Fi gateway, which is a whole home connectivity. So this platform itself has 8x8 5 gigahertz Wi-Fi. It has Zigbee, it's got Bluetooth, it's got Thread, it's got 4x4 2.4 gigahertz Wi-Fi, and its DOCSIS 3.1 as well. So it's an incredible box. So they've made that leap of faith that they can actually integrate the different IoT radios in here and make commercial sense of it. I guess the other reason they put in the 8x8 is they see if they can put one of these in rather than having to put 3 extra extenders, they're saving money. The dashboard piece here is just a way of picking up all of the different Wi-Fi devices in your home. So each one of those, if you have to think about it, each one of those Wi-Fi devices is an IoT device. It's just not a light switch. It might be a mobile or a tablet. So this dashboard gives you the full visibility, and then they can start to add features on top. Like for kids, it's bedtime mode, so they're shutting services down on a per device basis when needed. And then they're tying it all together into their voice service as well as their TV integration. So their set-top box UI is already tied in with talking and remote control for changing channels, but now they've tied it into the extra level of service for IoT. And finally, they bring in the whole notion of parental controls for all of these services. So they're trying to own the digital home in the same way people like Google and Amazon and all the other companies are. So they're trying to show themselves they can do it, but they're also showing to all the service providers it's a possible option. So I won't touch that again because we've covered it. So that's it.
Thank you, Ian. That was absolutely fascinating. Do we have some questions for Ian, please? We've got plenty of time, so if you do, please. Yes, please.
Hi. Thanks very much. That's very interesting. I was wondering what you think about if you look at some of the companies trying to put together IoT or smart home systems, like notably Amazon, Google. Amazon, Google, what's the other one? I can't remember. Amazon and Google. They very much seem to be trying to establish a closed ecosystem and go for a land grab and to establish the biggest closed ecosystem. Like Apple would be the other one,
Apple,
I guess. And how open do you think they are to cooperating with operators, or do they just want to disintermediate them?
I think Amazon are definitely open. The services that they provide, like Alexa, is available for everybody to use. Google, I think, are similarly minded. Apple HomeKit, the jury is still out because Apple, make money out of selling services, selling audio, video. They compete with service providers effectively. So it's very difficult to see how Apple plays in the space, but certainly the likes of Google and Amazon are quite open.
Yeah, I've heard the observation before that Google are much less open than Amazon on smart homes, which is sort of not the way around you'd expect it to be. But
but compared to Apple, I think both of those are far more open.
Thanks.
Do you think before we go to all of these, manufacturers make a better Wi-Fi box to work in the whole house, stop the technicians, give all excuses why it doesn't work? Because that's a bigger problem.
Well, I think there's two elements to that. The first thing is putting enough investment into the first gateway in the first place. It's only now that we're starting to see 802.11ac be deployed properly with the likes of Wave 2 technologies. So that's helping significantly. But the other part is physics. We can't, take walls out just to improve Wi-Fi. So we'll always end up having to deal with problem cases with Wi-Fi. There are some, if you look at some of the Amazon Echo products and the Google OnHub, what they've tried to do is make a product that actually can be moved front and center in people's homes. Okay? So it looks attractive and it can be positioned in the center of a home. So if you're talking about Wi-Fi, that's the best place in the home to position a Wi-Fi element as opposed to the point of entry where 80-90% of them are placed today. So that fixes some of the physics issues because it's not broadcasting all your Wi-Fi into the neighbor's home, it's broadcasting it within your home. So, the extenders are not going to go away, there are probably going to be more of them, they're going to be more complex.
Middle of the room then.
Middle of the room. But you can't run a coax cable to the middle of your room. So there's some challenges.